So in this video, we're going to talk about the basics of mass and volume. And we're going to do that from the lens of Democritus's model of the atom. And so Democritus took thought of something like this. Imagine you had a solid object, like a piece of paper. And what you did was, I'm going to do my best here, you ripped it completely in half. And here it goes. There. To where you had, if this was one particle, what you just did was you ripped it into two particles. That's impossible. That's what Democritus thought anyways. And so he thought that this one sheet of paper, before it was ripped, had many particles. If you cut it in half, then half the particles are here and half the particles here, and you could keep ripping and ripping and ripping and ripping and ripping in half until eventually what you're left with is this one individual particle. So now the question is, what are those particles? Well, those particles, we know them today as atoms, and then atoms are made up of things like protons, neutrons, electrons. But for the most basic part, we're just going to refer to them as particles for simplicity's sake right now. So they're made up of very, very tiny particles. So what if I had an incident like this, where I had a metal bar like this, and I had a metal bar like this. It's made of the same material, but what's different about these objects here? Well, one thing for sure is one is heavier than the other. One's more massive, okay? So we're going to define mass in this class as, right now, we're going to define it as the number of particles, okay? So if I were to represent this guy right here, as opposed to this guy right here, then what I might do is I might represent this one showing more particles than this one, kind of like what you see on your screen right now. Boom. So if you look at those, then you'll notice that this one and this one have the same shape of particles, but this one just has more particles. But there's something different about them as well. Other than having more mass, there's also something called volume, which is the amount of space that objects take up. So which one of these objects has more volume? Well, if I look at that, this guy is a lot bigger, so therefore it has more volume. It takes up more space. So therefore, I might define my object's volume by drawing a box around it, much like what you see right there. So now what you can see when you look at these particle diagrams is this one right here has more particles, but it also has a bigger box. And this one has less particles. In fact, it looks about, in terms of volume, it looks about half the height. And so therefore the box is half the size. But it also probably has about half the amount of particles as well. So this one is more massive because it has more particles. This one also is a bigger volume because it takes up more space. Basic principles of drawing particle diagrams. Mass represents the number of particles. If an object is more massive, then that means right now that it has more particles. If an object has a very large space, and that means that particle diagram is going to show a bigger representation by drawing a box around those particles. And that is the fundamental idea of Democritus's idea. So when you think about ripping up a paper, think about how many particles might be in this paper right here, and how you could represent that. I could even pick up something like this, and this is made up of tiny little particles, and you could draw individual particle diagrams for each object that you hold.